and this new standard that was released at the end of last year, which is IS 849103. And then how we manage these low integrity protection layers through the life cycle. So to begin, this is some time ago now. Like I said, it's almost a generation ago that, well, no, it's 2016 what I
Somehow we lost your audio, Ed. Yeah, you got muted somehow.
Oh,
there we go.
Yeah. Okay.
Okay.
All right. Let me continue. Okay. So in 2016, there was a fatal explosion that occurred at an air gas facility. Air gas is a manufacturer of gas cylinders for a variety of purposes, uh, mainly industrial. And so it does manipulate nitrous oxide. N2O is a gas that is both toxic and explosive, and it is used throughout several different industries. It is used as an anesthetic agent, for example, in the healthcare industry. It is also used as a ripening agent in food and beverage. And as a result, it just has quite a bit of uses. And unfortunately, the way that it's transported and dispensed into trucks um, um, has the potential for large explosions, and that happened on August 28th of 2016 when a technician died as he was dispensing this type of gas from a truck into a storage tank. And in order to understand what happened, I need to illustrate to you the basic arrangement for dispensing N2O from a trailer into that storage tank. And it uses a pump. There's nothing particular about this type of pump that is highly specialized. It is a rotational pump, and it does uh, 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 pump this type of liquid at that temperature to the storage tank. Now, even though I have illustrated the pump in the form of a cartoon, it's actually part of the truck itself. And what you see here is actually two different um, sources of conduit of the I'm just looking at the pointer of the liquid. You have one which is actually pumping the nitrogen in or out, and then you have another one for the air. So as you're either filling the truck or the truck is dispensing the liquid, a certain amount of air is going to have to move, and that has to be also managed through a different conduit. Now, because you're using a pump, there's always the potential of the material overheating because the pump may drawn dry. The pump draws dry, it overheats. This is a gas that uh, has a boiling point, I think, around minus 120 degrees centigrade. So it doesn't really take that much for it to overheat. And what has been typically done here is that there is I mean, it's a very crude mechanism, but the way in which a pump dry condition is identified is by having a flow meter. The flow meter measures the flow rate of the liquid, If that flow rate is within a certain minimum parameter, the pump is considered to be fully lubricated through the use of that liquid. If it falls below that certain flow rate, the pump is considered to run dry, and therefore that you have the potential for a much higher temperature, which will evaporate the liquid, and you have therefore the potential for that liquid to escape, come into contact with some competent ignition source, and create an explosion. The system, as I pointed out, is very crude. You have a flow rate, but there really is no means to detect the degradation of the flow meter itself. If you have studied functional safety, you know that for many systems there need to be safeguards, but safeguards themselves are not enough. Any safeguard over time will degrade, and so there has to be a means to either replace or arrest the degradation of the safeguard. That was just not the case here. And unfortunately, you happen to have a situation where the flow meter failed, the pump ran dry, no failure was detected, liquid evaporated, and it really didn't take long for it to find some sort of source of ignition, and you had an explosion of nitrous oxide. And unfortunately, the technician that was dispensing the nitrous oxide died as a result. There was a U.S. Chemical Safety Board investigation, and it is very instructive. And as a matter of fact, I encourage you to go to the U.S. Chemical Safety Board website and look for this particular completed investigation. What is interesting here, and I will just point a few of the important facts, is that the facility was not subject to OSHA or EPA safety regulations. And you wonder why? I mean, this is a perfect example of something that can happen. But under the OSHA process safety management standard, facilities must have a threshold of inventory of combustible or toxic materials in order for them to fall under the PSM standard that requires a number of different activities, including a process hazard analysis, which anything of this nature should have required. But again, this is a very small facility. Typically, the volumes for single 18-wheelers do not fall into this category. Again, didn't fall under OSHA, didn't fall under EPA. The second one is that the air gas lack any kind of formal safety management system to address nitrous oxide hazards. And if you read the report, you will find that Airgas was actually very cooperative. In fact, it got very high marks from the investigators for its response to the aftermath of this incident. But what became apparent is that I would say it's two things. Number one, that there was a very low standard of safety when it came to these type of facilities. And the second one that may surprise some of you is that even though the process safety management standard does not apply, there is an expectation from OSHA that companies are going to use standards, including, by the way, ISA 84, because that's a recommended and generally accepted code of practice, or RAGAGEP, as it's known, to try to manage and increase the safety standard of these type of facilities. So what went wrong, and what could be done to to manage it? Well, the first thing is what is known as the safety interlock. Now, if we had a larger facility, much more sophisticated, a refinery, an LNG gas compressor station, there will be a full review of process safety for all of the processes. But right here, a run gas safety interlock really didn't exist other than by the flow meter. And it is really not managed. And if the end user is very precise, they can easily point out that there's no standard that applies to it. Okay. And OSHA can say, look, you could have looked at the spirit of ISA 84 or PSM and done some work, but there is, in defense of the user, in defense of the user, they can say, really, there wasn't any standard. But I would point out what the CSB pointed out, the Chemical Safety Board. It says that although OSHA stressed the importance of applying ISA 84 to process not covered by the PSM standard, Airgas did not apply the standard to nitrogen oxide pump rise safety interlock system. The interlock is critical. And it says by applying the standard, Airgas could have reduced the risk of the pump starting a decomposition reaction, which is what happened. Airgas was fined. It wasn't found negligent. And there were a number of recommendations by the Chemical Safety Board to OSHA to try to fix what is known as this particular loophole of safety interlocks. You're wondering, okay, so what is a safety interlock and what does this have to do with anything? Well, if we take a step back, and I'm going to share something with you, is that there are many mechanisms that are used in industry that do not require a logic solver to perform some sort of safety function. That may surprise some of you. But if you use a simple setup like the one we just saw with Airgas, if you use just a simple sensor with relays to actuate a valve, okay, you are bypassing the use of a safety instrumented system, perhaps. And many users have the prerogative of doing that. They may not need to spend a lot of money in a safety and a process safety system in order to perform a small safety instrumented function. And up till now, many people, I am saddened to admit, use this as an alternative, a lower cost alternative to manage their processes safely. The idea being, if I can only avoid using a safety instrumented system, maybe ISA 84 does not apply to me. And you may think, Ed, that is just very crass. Nobody's going to do that. I'm not hearing any of you, but through my own experience, I've learned of many companies, and not small companies, big outfits with large number of manufacturing facilities where they have taken that approach. Well, no more. ISA has closed the loophole. It has defined what is now known as low integrity protection layers, or LIPLs. People just pronounce that LIPL. If you have heard the term LIPL, this is what it means. It's a low integrity protection layer. So you may wonder what it is. So I'm going to give you the formal definition under the standard. It is a protection layer used to meet minimum risk tolerance criteria that does not have a reduction claim of greater than 10. So the best you can do with a LIPL is to assume an order of magnitude risk reduction. Okay? The other important piece here is not intended to conform to ANSI 61511 requirements. This is interesting. So Even though you are not subject to the full-fledged requirements of IEC 61511, you must meet certain standards for this integrity protection layer, this independent protection layer that has lower integrity. Okay, so you can take it as a subset of instrumented protected systems. So an instrumented protected system can be an SIS, but it can be also a LiPo. So what are some of the examples? Well, setups with pumps and flow meters, relays, and sensors are some of the examples. Okay, anytime that you use a safety interlock for a valve, that could be considered a LiPo. Okay, but what is important here is that you are treating it to the same rigor as safety instrumented systems. Okay, so it is going to undergo the same rules under bypass management. You will need to maintain it with inspection, testing, and preventive maintenance, just as you were maintaining a safety instrumented system. And just as with safety instrumented system design, if you want to modify or upgrade the system, it has to go through a system life cycle. And I know it's a little small on the screen, but here I'm just pointing out to the safety instrumented system life cycle. It is not identical to the one of an SIS, but it is very similar. Okay, you go through an identification and clarification space, you go through functional safety requirement specifications, you go through detailed design, you go through the implementation, meaning that you have to procure, you have to build it and install it, and then you run it. It is operated, it is maintained, and it is monitored for performance. And if you decide to change anything, it goes again through the system life cycle. There is no excuse. So as it happens, because it's not an SIS, you can control your LiPos through your basic process control system. Okay, so they can be integrated into a BPCS, but here is the kicker. According to the standard, okay, if you use it with a BPCS, at most, you can assure yourself an order of magnitude reduction in terms of your risk. Any higher claim that you want to make for your LiPo requires it to be managed under 61511. And again, this is a mechanism to prevent users from trying to claim more than they should by these low integrity protection layers. As I said at the beginning, this is extremely important because there are many people in this country, and I suspect around the world, who believe that a safety interlock does not fall under any standard. It does not need to be managed. It does not need to be designed. And unfortunately, it can have perilous consequences. So what have we learned? First of all, I think that this air gas explosion just highlights the consequences of these setups involving low integrity protection layers. Having a non-SIS protection layer is not in itself a way to avoid going through some rigorous treatment of process safety. And through a combination of ignorance and really poor follow through on standards, Airgas had a system that was at very high risk, and unfortunately, a person lost his life as a result. The other point is that with the new standards, low integrity protection layers are given a place. They are not subject to the scrutiny of SIS, but at the same time, they are not left completely unattended. They do play a critical role in achieving acceptable risk levels. I would say that as we propagate IAC 849103, we're going to raise expectations among end users that they need to apply lifecycle management practices to things that they had not consider as subject to those practices before. And again, we can look at bypass controls, document management, management of change, testing and inspection, all fall under this standard on the use of LIPO. A common theme that I find, especially because these tend to be used specifically, not specifically, but more often on small operations, like very small plants, that they may not be part of an SIS. They may be, just completely standalone. But if they're part of a basic process control system, once more, you have only a maximum risk reduction factor of 10 that you can claim. That's the maximum. It is not intended to be a way to circumvent ISA 61511. And what is important for me more than anything is that this proactive application will improve or raise our standards for safety beyond SIS compliance. So with that, I want to call to your attention a few references. I think that this is going to get much more scrutiny as people realize that the standard is now published. I was waiting for it to be, by the way, it has been under review. Well, it has been over 5 years in the making, and it has been under review all through the fall of last year. And I thought it would be released by October, but as it turned out, it was published in December. But here's the standard. It is available in the ISA website. I also will give credit to Angela Summers for her very nice, very comprehensive paper on LIPOs. The previous name was safety controls, alarms, and interlocks, okay, or SKY, but it just didn't roll off the tongue as well as LIPO. And once again, I think that it's very instructive to read these accident investigation reports by the U.S. Chemical Safety and Hazard Investigation Board. And that's the one that I was referring to right now. It is the nitrous oxide explosion near Pensacola. Any questions?
Since I'm first to raise the hand, I'll just speak up.
Okay, all right.
I went out, and apparently while I was doing that, the bandwidth of my computer going out to the website at the Chemical Safety and Hazard Investigation Board website and capturing those documents, which I sent to you by email, each of you, courtesy copied you, Ed. You probably already have it. But I did that via email because I couldn't attach anything to the chat, which was weird. Because Teams, you're supposed to be able to do that. So I don't know what happened there, but and apparently it was upsetting. It was pixelating your voice as I was
Huh.
doing that. So that was kind of weird. But
Yeah, go on.
so in terms of questions, um, I did not hear you say what the rationale was behind UL not in your first slide and the
Mhm.
4 bullets that you had there.
Okay, let me go back there. Okay, yeah,
Mhm.
this one.
No, prior one. Oh, you had one that kind of was an introductory slide that had, I thought, 4.
Yeah,
There it is. That's the one.
yeah.
Um, you said OSHA um, is the facility was not subject to OSHA or EPA safety regulations that govern despite history. Why? How does that happen? Did you answer that I missed?
Yes, yes. So, uh, facilities that contain chemicals are subject to the process safety management standard, uh, provided that they meet certain volume of combustible or hazardous materials.
Oh, ah,
And those are listed as an extensive list of substances that are considered to be hazardous chemicals. And
mm-hmm,
it really varies. It's over 10,000, gallons in one. It's smaller quantities in another.
sure,
And nitrous oxide doesn't meet that threshold. I
gotcha,
mean, if you were
gotcha.
if you were a refinery, if you were an LNG facility, if you were an LNG terminal, yeah, absolutely,
Yeah,
you'll have to meet PSM. But these are smaller facilities, and so up till now, uh, PSM, these facilities fly under the radar of PSM. Okay. Uh,
gotcha.
yes, yes. Uh, Now, the U.S. Chemical Safety Board pointed something that is very pertinent, and that is PSM. PSM has a number of requirements for facilities. The very first one is if you're subject to PSM, you must perform a process hazard analysis or PHA. And you need to review that PHA at a minimum every 5 years. That's by law. If you're in the United States, that's the law of the land. Now, when it comes to a smaller facility, and I would also say PSM gives the end user the ability to pick its own poison. It it's amazing, but it says you can tell us what is the process safety standard that you will follow to meet PSM. And one of the most common one, because it's just so widely adopted, is IEC 84, IEC 61511. It is considered generally accepted and generally commented and accepted uh, uh, practice or ragadem. And in in the following slide, I pointed out the comment that the U.S. Chemical Safety Board made, and that is it pretty much pointed out to the user, to Airgas, look, although OSHA stressed the importance of applying IS 84, you should have known this could apply to you. You did not apply IS 84. And in fact, I mean, I'm just quoting chapter and verse. By
Mm-hmm.
applying IS 84, Airgas could have reduced the risk of the pump starting a decomposition reaction. As I said, this is something that marks the difference between following the standard because you want to make sure that your process is safe, even if it does not necessarily, even if you're not compelled by law to do that, or waiting until OSHA or another organization comes down on you with the full force of the law. So it's an important comment.
And especially after prior incidents, multiple
Yeah,
prior incidents. So
it,
that's the staggering thing to me.
yes, and it's interesting that you pointed that out. But if you perhaps you have already read part of the standard investigation report. The investigation report points out numerous accidents that occurred with nitrous oxide that resulted in explosions. So this
Yes.
was nothing new. And again, the report doesn't say ignorance is no excuse, but if you read between the lines, it's saying ignorance is no excuse. These are all of the incidents that occurred prior to the one that occurred at your facility. You should have known better.
Yeah, I
You
mean, you're a gas supplier, you're a gas manufacturer, gas supplier. You're doing this stuff all the time, and you
Mhm,
have to be keeping track. Well, if you're not
mhm,
keeping track of incidents
mhm,
of of incidents that involve gases that you produce, whether
mhm.
you had an impact on those prior incidents or not, you should be learning from those incidents, and they weren't. And I'm surprised
Exactly.
OSHA didn't come down on them.
Yes, yes. I would have said ignorance is no excuse.
Right.
I read this particular um, excerpt of the report as a statement of ignorance is no excuse. You should have known better. Now, because these type of incidents have been so common, uh, ISA 84 thought, or the ISA 84 working group thought that it needed to um, be far more uh, articulate much more what should be the behavior of these end users, how should they apply ISA 84. And so it created this concept that, it, like I said, it went through different terms. It was called safety interlocked um alarms, and what is it, safety controls, alarms, and interlocks. And it's now called low integrity protection layers. Okay, so you can consider it almost like an intermediate step. It says you have to meet a number of the same requirements that you do with the SIS without 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 that extensive force. It's kind of in the middle. It says you you have you have to meet at a minimum what is required under the new standard. Okay, and no, the fact that you put it with a BPCS doesn't allow you to claim more than that, and that is to prevent people from uh, trying to circumvent having an SIS.
Now, because Jonathan works for a gas company,
Mm-hmm.
Yes.
he knows where I'm going with this. I was just going to tease, but the 61511 is a is that an ANSI instance of 84?
Yes, so ICE 84 uh, merged with IEC 65111
Gotcha.
to have a harmonized global standard.
Sure. Yeah.
And
As we've
and,
seen.
and it is by far the most widely globally accepted as standard for process safety. And as I repeat, in the United States, uh, I say 84 right now, I say 61511 because of that harmonization
Mhm.
is considered a generally accept. This is OSHA that has
Mhm.
stated it. OSHA states that it considers it a generally accepted and recommended code of practice. Okay, so if you have a facility and you know from the process safety management standard that you must perform process hazard analysis, and you need to know how am I going to manage this through the life cycle. If I find that I have to have very high risk reductions and therefore have to have safety instrumented functions. One way to do it is through ANSI ISA 61511.
Well, and as you and I and many of us know, that compliance to regulations is never really expensive if you consider the ramifications of an incident, whether it's monitored or investigated by OSHA or some chemical safety board or not. For someone to lose their life as a result of an incident because you weren't following safety protocols, that's way too expensive. That's way too expensive.
Yeah, I would say most of the, of course, we're talking about a subset of the industrial automation profession, but
yes,
professionals who are functional safety managers or a minimum are familiar with this standard will find the new standard to be quite easy to interpret, and you might call it even ISA 61511 light. They will follow it. They know what they need to do. The challenge is that typically those are the people who are not doing this. When you're looking at these small companies, and Airgas is no small companies. Let me rephrase. If you're looking at these small facilities, a little truck loading station, or who knows, the trucking facility, the flying horse or whatever you call it these days, that has a couple of tanks, they may just not know. That is the problem. It's just that they may think, oh, I have operated like this all my life. I don't even know what I need to be subjecting my products to. They may not know. That's the problem. Is that many people are not aware that they have to meet this type of standard.
That's an interesting thing that you brought up, because as you know, as you may not know, I've been active in the Idaho National Labs cyber-informed engineering working groups, and trying to bring some organization to that Department of Energy funded effort. And part of what in this second year, actually starting the third year, holy cats, part of what we're looking at is ways to get the message out. And one of the things that has not been discussed or brought up, and I didn't think of it either until just this minute. I was going to ask whether your ISA 84 committee, because you're in that, right? You're part of that working group.
No, but to correct, I'm not part of the committee. I work with people who are voting members in the committee. I had access to the draft standard.
Gotcha.
And so I've been familiar with it as a result.
Yeah, so you know these people. You could make a suggestion that is as a potential next step or next half step is how to improve. What's the acronym SEO, Jonathan? Search engine optimization? Yes?
I don't know.
Yeah.
I'll say it
okay.
right.
Yes.
SEO, search engine optimization.
Yeah,
yes.
search engine optimization for what would it be? Safety regulations for the gas industry? Is that what it would be? As a generic search engine phrase?
Sure. Yeah. Well, we could do it for gas. This is applicable to anything. You could have a hospital with a lot of nitrous oxide, for example.
Of course.
You could
Dentist
have
office.
a business office.
Right?
The dry cleaners, even though they're not using nitrous oxide, they use some chemicals that are. I mean, they have their alarms. They have their interlocks. Yeah.
And so somehow improving the search engine optimization for ANSI ISA 61511 across a number of different kind of subjects. And that might be something that that the ISA 84 committees or committee could adopt or look into as a next step into 2026
Yeah, yeah.
for that
I
new regulation and so that's cool. That's good
Yeah,
stuff.
no. Thank you. I take your advice to heart. I'll talk with the two people. I actually know more than two, but at least two of my colleagues who are voting members of ISA 84 about, you know,
Yeah.
this next area for the working group to explore.
Right. How to spread the word, right? We can't
Yeah,
just as a ISA, just as an SDO, standards development organization, can't just like publish this stuff and let it sit on the shelf. We
yeah,
got to
no,
promote it. And that's
yeah,
part of what ISA has had, kind of challenges doing over the last decade or so, right?
hmm
Is being able to promote. I mean, IEC 62443 was adopted because somebody at IEC said, "Oh my God, we could use this and get this around the rest of the world." And oh my God, it's really applicable to more than just industrial automation and control systems.
hmm
And we should make it a horizontal standard. And ISA never thought about doing that. So
yeah,
just interesting, some of the things you see in hindsight.
yeah, yes. No, and this will again, many of the facilities that we probably do not associate with chemical process, for example,
Mhm.
use all of these type of devices, safety interlocks, alarms, um, you know, controls, safety controls. So yes, I mean this really expands the breadth of what the broader ISA 84 standard regulates. Okay.
Yeah.
I don't mean it in the sense, just to expand for the sake to expand. It is a group of facilities that have a very poor standard of safety.
Yeah.
A lot of people have lost their lives as a result. I gave you just one example, and
Right.
thank you, uh, yeah, Tom, for pointing out that many of these accidents have been occurring for many years
Yeah.
prior to 2016. And so, I mean, we are trying to solve a real problem here.
Yes. Yes. Well done, Ed,
All
for your
right.
involvement with it. Thank you for sharing.
Oh,
Interesting
I
stuff.
you're welcome.
actually, before you, if you can bring back the slides,
Oh,
I
yes,
just have
yes,
a
yes.
few quick things. Um, One thing, I like that you point out that the standard isn't just having, the equipment for interlocks
Mhm.
and the alarms and the software, hardware to put the two together, but having the maintenance plan and keeping that maintained.
Life
Yes.
cycle. Yeah.
Yeah.
Life cycle stuff.
It is
But
exactly. It's the life
because
cycle.
the two have to go together.
Yes.
And yeah, Centerpoint uses LNG, not much, but
Mhm.
that is definitely something they have to be very strict about. I was blessed to see their LNG facility, and like that was pretty neat how they can deal
Cool.
with that for reserves. But um, that standard that you have, I imagine that is um, a guideline that's means slightly different things based on your situation. Would I guess that you have to, whatever mechanism, identify your base risk without any layer. And if you want to lower it by 10% at best, um, you, you would then like, okay, um, go from there. It's like, so like there have to be some risk analysis of your system as it is. And
Y-
then
Yes.
you would add
Yes.
the low integrity protection layer on top of that.
Yes. Yes. That's a
If you
that's a that's a very good point, Jonathan. Uh, Again, these low integrity protection layers are typically involved when there is, I mean, by definition, a very small decrease in risk reduction expected. Okay. You know, and that typically applies on things that have, you know, that have not as severe consequences. That I probably could say where the consequence is not severe. Uh, if you know that you have to undergo several orders magnitude of risk reduction, a LiPo is really not the mechanism
No.
to help you achieve that. You really need to go through a safety instrumented system.
Yeah. Yeah.
And it isn't, this is, your question is actually more poignant than perhaps you realized. There are people who unfortunately are going to try to use LiPo over LiPo to try to get LiPo on top of LiPo to try to get several order of magnitude risk reduction. And that on itself is bastardizing the standard. That was never the way it is intended. It really is not what they're supposed to do. Tomorrow, I have a meeting with an end user on a flare drum. Now, they're not, nowhere in their process are they considering to apply a LiPo. However, their approach to the problem is that they just need to make small increments of risk reduction to allow them to get to the level that they want. They're not considering the fact that they need to review entirely the process to come with one, perhaps two steps that are going to help them achieve their sale target. Okay?
Gotcha.
So does that result from a risk assessment like you would do for cybersecurity?
It
Or
is,
does it,
yeah,
okay,
it is,
safety risk assessment? Okay.
right. Well, that's what a process hazard analysis is,
Ah,
Tom.
process hazard analysis, yes.
Okay.
Yeah,
I've
that's,
got, I've
so,
got,
yeah,
sorry.
go ahead, Jonathan.
I have one last question, but I want to make sure if Bob or Sally have any questions, they have an opportunity to ask. But if you can go to that slide where you show the system that's in the truck, I just want to understand, was the fault in the truck not being safety designed, or the interface between the truck and was it an external storage tank that it was like dropping the gas off, and where was the safety problem?
The uh, the problem was on the flow meter. Well, first of all, you could argue that you really need to do entirely your entire mechanism for managing the dispensing and uh, filling of 18-wheeler tanks. But in this particular case, this pump with this flow meter, these are actually in the truck itself. I mean, they have been blown up here so that we could have this discussion, but they're really part of the truck. Uh, the problem was that the flow meter failed. If the flow meter fails, that should have alerted people right away that you really could not see whether there was a um, low flow rate of nitrous oxide, and as a result, the pump began running dry. You started that decomposition reaction as the temperature increased due to the friction within the pump itself, which
Right.
caused, which led to the gasification of the nitrous oxide, which led to the explosion.
Oh, boom.
Yes,
Yeah.
yes.
Wow.
And Jonathan, that's exactly one of the first things that you do in a process hazard analysis. You look at nodes, you say, okay, what is the hazard? And you say, well, the hazard is an explosion of nitrous oxide. And then you ask yourself, how could it have occurred? And you look at, okay, how do you prevent it from occurring in terms of this particular a decomposition reaction as a result of a pump run dry situation is fairly common. So how do you prevent it? You prevent it by having a type of sensor. But you do not stop there. Your rationale stops there. You need to ask yourself, how how are the safeguards? The other term people use are barriers. How are barriers or safeguards degraded? And how do you arrest that degradation? Well, if you know that this sensor is that critical, how often do you need to maintain it? How do you know when it is not working? And what happens when it fails? Then what do you need to do? If you had designed this properly through a PHA, you would have had some bypasses. You would not have depended on one single sensor, ever.
Thank you. Does anyone else have any questions or comments?
Excellent. Just thank you, Ed, for at the last minute coming back and wanting to do and being able to do it tonight.
Oh,
And if it's a dry run, so
mhm.
be it. But I
Yeah,
think it sounds like we have a recording. We'll have that done when Bob can't ends it, and we can review it or we can just post it. Whatever.
yes, yes. And let me know if you want me to do this for a broader audience. Um, I I mean I like the topic. It's 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 one of these, what do you call it? Important safety messages. I
Yes.
like the fact that it it underscores the value of ISA to prospective members. But in addition to that, it's as I pointed out, it's the real deal. People are making they are incurring unnecessary risk when they devise systems that uh, are not sufficiently safe.
I have a question that just came up as a result
Yes.
of talking about, the recording and who might, and Shar in her new member and
Mhm.
role, I saw early on that she was really interested in bringing some of her Emerson folks, and
Mhm.
she's in the Rosemont division, correct, Ed?
I think she is with the Aspen Tech group,
Oh, that's
which
right. That's
yeah,
right.
she's with she's her role is primarily um, on energy management.
Right.
Although I would say that you know some some processes within plants may be subject to the standard.
Sure. Sure. And what I was getting at was that she was going to start bringing some folks that she knows at Emerson that you may also know because you worked with her there, correct?
Yes, yes.
Yeah. And so there's more of a chance to get a wider um, spectrum of
Mhm.
questions from those people who talk about this stuff, every day,
Yeah.
handling gas, measuring gas, measuring flow in liquid and gas. And so, I'm thinking that we might want to just ask if anybody wants to view the video and we all chime in, whether we would like Ed to do it sometime this summer. Um, Perhaps we assemble at Forgotten Star where they have a back office that could accommodate 30, 40 people and we display it there, or you give the pitch there and we can do that. That would be kind of
Okay.
fun.
All
And then we
right.
can get people from a variety of companies come and listen to your pitch. And I know some engineering folks who would probably be interested.
Good. Very good news.
So,
I highly recommend that, yeah, that we ask you to do this again with plenty of preparation and all that. And
yep.
I think it might be best to do it fresh so we get fresh questions, interaction, whatever. But thank you for
Yeah,
Oh,
and
doing it now and in the future.
and if Bob wants to just capture the presentation and these kind of questions and discussions, there's
mhm.
something else I could talk about with related to the things I committed to do. And he can end the recording now, and then we don't capture that portion um, for other people to watch. Copy me, Bob?
Yeah, can you hear me now?
I
Can
can.
hear you.
Okay, let me stop the recording.
Okay.
Because we have some board members here, and I had committed to try and get, a tour of the Prairie Island Nuclear Facility. And I
Bob,
had
it's not
sent,
stopped yet.
Oh.